All right, good morning, everybody, and welcome to our Firm Research to Implementation webinar series for February. We're excited to have you guys, and this is a really fun topic to me. Talk about the mixed design tips for recycled and kind of non-standard materials. There's a lot of interest in that, especially as we move into balanced mixed design and starting to see what these different materials are going to do to our mixes and how we can incorporate those in to see if we can get the benefit that we would like in our pavements. So today we've got Nathan Moore is going to be with us. We've got Graham Hurley, who's one of our research engineers, and we've got Sadish Banda, who's with Sunland. He's with their research arm or their design arm of that. So I'm going to go ahead and introduce everybody. I want to remind you, please keep yourself muted. Um, I'll put a reminder in the chat box that any questions that you have for the presenters, let's type those into the chat box, and we'll divvy those up at the end. So, Nathan Moore is an assistant director for the Test Track Research here at the National Center for Asphalt Technology. He's responsible for overseeing all the Test Track research programs. His role prior to that, Nathan served as a research lab engineer for about 8 years at the NCAT lab, specializing in balanced mix design, pavement friction. He's got both his bachelor's and his master's degree from Auburn University in civil engineering. He's a licensed professional in Alabama, and he is learning how to put together trampolines again because he lost his trampoline in a storm a couple weeks ago, and his kids want it back. So Graham Hurley, he started his career in asphalt industry as a co-op student at NCAT about 27 years ago. He then worked as a part-time student for NCAT as he worked on his undergraduate in civil engineering. After graduating, he joined NCAT full-time as a research lab engineer, and during that time, he also spent plenty of time studying, and he earned his master's degree with a focus on warm mix additives in asphalt. In 2007, he joined Dr. Brian Prowl as a project engineer for Advanced Material Services. And then in May of last year, we stole him back. We're really glad to have him back at NCAT. He rejoined NCAT as an assistant research engineer, and he's having a lot of fun chasing a late teens daughter as she's going through her high school adventures, and he does a lot of things to participate and help her out there. Sadish Banda, he gained his master's in civil engineering from Kansas State and has worked in the asphalt industry since 2001. He's currently the technical service manager for Solterra Materials, which is a division of Sunland Asphalt. He's located there in Phoenix, Arizona. Sadish has experience performing a combination of laboratory and field testing of construction materials, asphalt mix designs, engineering analysis, and technical training services. He maintains his professional engineering license in the state of Arizona. So, given that, Nathan, I'll turn the time over to you.
Thank you, Travis. Um, if you go ahead and go to the next slide. Many of you guys who are on this webinar, I want to thank you guys for being here. You guys know the drill. I'm just going to introduce the topic. I'm going to speak for as little as possible because I want to make sure that our experts who are on this webinar with us get their chance to show their perspective. So after I introduce the topic, Graham will talk about NCAT research specifics in non-standard or alternative materials, and then Satish will show us an industry perspective. Travis already mentioned, but please remember to put your questions in the chat. You don't have to wait till the end. Just go ahead and as you think of them, go ahead and type them into the chat, and we will get to them, and then we will close out. So, history at NCAT. NCAT has experience with lots and lots and lots of alternative materials from well before my time. During my 8 years as a lab engineer, I got all kinds of experience looking at recycled rubbers and plastics and lightweight aggregates. And I'll never forget a project where we were trying to put somebody was trying to put seashells in asphalt. But then there's other, when we say alternative materials, this is what we mean is just kind of not your bread and butter, normal everyday run of the mill stuff. So calcined bauxite, steel slag, taconite, glass, recycled concrete, sulfur. There's lots of different additives that I think Graham will get in. Graham will touch on the liquid side. And the use of recycled materials is really increasing, both in the type. So, in the past 5, 10 years, we've seen recycled plastics really kind of come onto the scene, and there's lots of different technologies now looking at how to incorporate that into asphalt, but in a way that is successful. But also, you just see the amount. I mean, the usage of wrap is increasing, usage of rubber is increasing. All of these, they fall under the umbrella of sustainability. It's not just trying to make a greener product, although that is being done, but how can we actually blend these into an asphalt mix and improve performance, improve durability? But the purpose of this webinar, and I hope you guys will enjoy the content, is how do we need to think about these materials inside a job mix formula? How do you incorporate this stuff within a mix? How does it change your gradation? How does it change your uh, densities and your absorptions and your all that kind of stuff? So we'll go ahead to lessons learned, Travis. Next slide, please. So from this is just my perspective, and then I'll let Graham and Shathis really dive into the details. But you have to know your fundamentals. You have to understand, okay, is this alternative aggregate, is it more dense or less dense than the typical materials that I'm using? What is the melting point of whatever this additive is? Or honestly, what is the flash point? Can I even put this in a plant? Is this dangerous? Sure, it maybe can be done in the lab, but how is this going to work when it's running through a plant during production? And you can't ignore material properties. You have to, even with more at this point, honestly, they're standard alternative materials in wrap, and even in some places still shingles. Um, don't ignore those basics material properties. I love to think about basics. I love to think about whenever I'm trying to change something, how are the basics, the building blocks, how are those changing? So, for example, if I'm throwing something that's a really fine powder into the mix but doesn't melt, how is that affecting my gradation? How is that affecting my particle distribution? Um, or let's say you throw in a great example is rubber and plastic, which have lower density than aggregate. So how is that going to affect your rice values? How is that going to affect your GSE values? How is that going to affect target density in the field? How is it going to affect compaction? How is it going to affect absorption? I think putting on a thinking cap before you get into these materials is helpful. Even if you set expectations for what's going to happen and they prove wrong, that's still a healthy exercise as you try to plan ahead. What kind of things do I need to be anticipating? I will always harp on specimen preparation from my time in the lab, and then even building the test track this past summer. Specimen preparation is key, and a lot of these materials, to be honest with you, make it harder. And maybe harder is not the right word, but they can affect it in ways that traditional asphalt binder, traditional aggregates, traditional or even recycled products, that they don't have the same effect. And so Graham's going to talk a little bit about that. And then the last thing I would say is sample frequently. It Doing one test and saying, all right, well, this additive or this alternative aggregate, it does this. That's not sufficient. And most of you guys know that. But if you really want to understand the material, sample frequently. Sample before it goes. If you're running it during plant production, sample it on the cold side, and then sample it on after it goes through the drum. Understand what's changing, and it'll help you be more efficient with these materials to optimize them and to know actually how to use them and honestly exploit them for your purposes, and how can you actually use them to achieve your goals. So I don't want to take up any more time. I'm going to hand it over to Graham, so Graham can discuss NCAT's history with, or his personal experience with this.
To the webinar. Again, let me just introduce myself personally. My name is Graham Hurley. I've been in this business for close to 27 years, going all the way back from the co-op days when NCAT was still in the basement of Harbert at the university on campus. Now I'm circling it all the way back around to this lab. So again, so what I want to speak on is exactly what kind of mix design tips do we have available to us in our toolbox when we're doing mix design with these recycled or alternative and non-standard materials. A quick little history of where the topic came from. It started right outside my office door here in the hallway of the NCAT lab. We had just finished paving a section of the test track this past summer, and we were talking about some of the issues that popped up during the mix design. It was a new track section that was looking at friction and using this alternative material. It was a bauxite material, and it had a specific gravity of 3.410, to where all the other aggregates that we used ranged in gravities between 2.602 and 2.689. So we had a great range of gravity values. And so some questions this mix presented was, one, well, how do we handle such large differences in GSB values? And if we can successfully put a great performing mix design together and have it function in the field, what can we do with any other recycled or alternative or non-standard materials here in the lab, and to successfully do a full-fledged mix design? So the question is, what is a recycled material? What about alternative materials? What about non-standard materials? What about just plain old waste? We've been the asphalt industry has been tossing things in asphalt to see if they would stick, going all the way back to the late 1960s. So this idea of using non-standard aggregates and materials, it's not a new concept. It's been around for a while. And I've just showed just a quick little list here. We started all the way back with glass. And it even gained a term. We were using glassfault, all the way back in the late 1960s. And then they thought about powderizing ceramics and porcelain and seeing what it would do to asphalt performance. Going all, and then switching gears and looking at wood lignins, and then coal mine refuse, and then RAP and RAS, recycled asphalt pavements, recycled asphalt shingles, and then moving to a little bit more modern ground tie rubber, and then recycled plastics. Ink toner. Ink toner is an interesting one in the fact that when I was working for Advanced Material Services, we did a lot of work evaluating ink toner and its performance in asphalt pavements, to the point to where now it is an accepted for use in asphalt in the state of Virginia. And then there's wax, and Nathan mentioned melting points of wax products, and we can talk about that as far as what can it do to improve our mix designs in the lab. So the question is, do we design by volume, or do we design by mass? Especially when we're blending aggregates with different densities, it requires some extra consideration. Do we do the volume approach? Do we do the mass approach? And it's especially important for friction, because a lot of aggregates out there that are specifically designed and used to enhance friction are really heavy materials. So it goes all the way back to the old riddle about what weighs more, 10 pounds of rocks or 10 pounds of feathers? Well, obviously the answer is they weigh the same, but the volumes are very different between rocks and feathers. But in the asphalt, especially for mix designs, we're not dealing with rocks and feathers. We're dealing with rocks and rocks. But when the rocks have different densities, the volume of a single aggregate particle may be the same, but the weight is very, very differently. So instead of having rocks and feathers, we can have a golf ball and a ping pong ball, where relatively the volume is the same, but the weights can be very, very different. So imagine this. Imagine someone asks you to collect a bucket of ping pong balls and a bucket of golf balls, but make them equal. If you did this by mass, you'd have 17 times more ping pong balls than you would golf balls. But if you did it by volume, you'd be slumped over to one side because the bucket of golf balls would weigh so much more than the bucket of ping pong balls. But we're not dealing with aggregates with this degree of difference. You know, we're only talking about somewhere between 0.3 and 0.5 as far as GSB values, but that can be up to 20% in some cases in values. So, for example, Mix Designs in Texas, they require that if your GSB differences are greater than 0.3, you must blend by volume instead of mass. Okay, so Texas forces you to use the volume procedure if you have a wide range in GSB values. Thus, when we're talking about dealing with materials like slag, you have to consider the true gradation of the material by volume. All our mix design parameters are volumetric relationships, so we're talking about volumes and not mass. However, we blend by mass because it's easier to measure and it usually works. Okay, but there are some times where things get a little squirrely. But the true voids in the aggregate structure or gradation, they can be different when considering volume versus mass, especially if the materials are not all similar density. So if we take this particular slide here, so we have a blending example here. So where we're blending this material by volume and by mass, just to show the difference between the two. So 52% of this blend is a limestone with a gravity of 2.450, but 48% is a slag with a gravity of 3.270. So we get a big gap in the big change or difference between these gravities. So what you see in the chart is by volume, the heavy aggregate will skew the gradation line by mass coarser than the actual volume gradation, and the light material will skew the gradation line finer by mass. It's because the fewer the heavy particles are needed to make up the same amount of mass as traditional aggregate. Fewer particles means less volume, more particles for the lightweight material means more volume. Okay, so that's just a quick little explanation of how to design versus using the mass approach versus the volume approach when we're dealing with materials that have different or a big difference in specific gravities. Now we're thinking about things that actually may swell in our mix design procedure. So expansion of gyratory specimens, it can turn after compaction, okay? If we're dealing with ground tile rubber, we're dealing with specific types of plastics. Now, not all plastics are the same. Not all ground tile rubbers are the same. So it's product dependent. So what we need to do is we need to think about how can we prevent this or minimize this swelling to occur? Well, if we're compacting using what we call a baby compactor, whether it's a Pine G2 or the smaller Troxler version, those compactors that actually the ram will come up from the bottom. So what we can do after compaction, we can not retract the ram and we can just leave the ram up. We can open the door and cool the mold with the compacted sample inside, cool it down with a fan, try to reduce that the amount of swelling after compaction. But if we're using a much larger compactor, whether it be the Big Pine or larger or Troxler, we can actually use an external weight, whether it be an old cored out gyratory sample or an additional top plate for the mold, just something that adds a little weight in our on top of our compacted sample, just to try to minimize any kind of swelling that may occur in our samples. So the ultimate goal is to reduce the amount of swell, but we're not going to eliminate all kind of swelling. So when we do have dealing with either GTR or plastics, we want to pay attention when calculating the corrected optimum asphalt content. Okay, we definitely want to follow manufacturer's recommendations for heating and mixing our materials. And after our samples have been compacted, we've done all we could to minimize the swelling. We want to basically, when the samples are fully cured or cooled down, remeasure the compacted samples, just to ensure there's not this excessive amount of swelling that has occurred. Even though we were trying as much as we can to minimize this swelling. Beware of false volumetrics. Now, what do I mean by this? Well, there was the myth or the rumor that recycled plastics reduced the optimum asphalt content of our mixes, basically by reducing the binder absorption. And the thought was that when we added the plastics onto our hot aggregate, the melted recycled plastics coated the aggregate surface. So in this coating, it basically reduced the binder absorption that would have normally taken place. And if we reduced the binder absorption, we had more effective binder. So our volume of effective binder was higher. So therefore, our optimum asphalt content was going to be lower. But once we treated the plastics as its own separate phase, in the end, what we found was that the plastic material basically tricked the volumetric properties, and it was not really reducing the binder absorption. So if you look at volumetric properties, especially when we're talking about the dry process, and this could be for both ground tile rubber, and it could also be used for plastics, you want to include the additive phase as an aggregate. Basically, what you want to do is modify the volumetric calculations. So you can see the adjusted and modified volumetric calculations on the right-hand side of the slide for VMA, the effective gravity, and the effective binder absorption. And you can see where we've added the ground tile rubber or the plastics as its own separate phase, because GTR has its own gravity, plastics have its own gravity. Okay, so we needed to really separate those out from the percent stone. So you can see where for VMA, you can see where we're taking the percent stone and dividing it by the gravity of the stone, but we're also adding the percent additive by its individual specific gravity to get an adjusted or modified VMA, which is actually a little bit more accurate in terms of volumetric calculations when we're using GTR and plastics. Okay, so for plastics, it corrected the binder absorption values, basically indicating that we did not have increased binder absorption, so we really didn't have this drop in optimum asphalt content during our mix design process. So a lot of states are moving to having a rutting criteria as part of their mix design process. I know Georgia has it. I know Alabama has it for some of their mixes. So my thesis work dealt with the very early warm mix asphalt technologies. And one product that we evaluated was Sasabit, which is a synthetic paraffin wax. And so what we found was that the paraffin wax, the addition, even in small amounts, will improve the rutting resistance of our binder without having to change the grade of our liquid that we were using during our mix design process. And what this happened was we knew that Sasabit or paraffin wax had a melting point of about 200 degrees Fahrenheit. So anything under 200 degrees when it started solidifying, it created this lattice structure in the binder. Basically, that lattice gave you almost a 1 PG grade bump in our liquid, and really improved the rutting resistance of our mix. So I don't know how common this is actually being used today in mix designs, where some of your mix designs may be a little bit susceptible to rutting, but this could be another tool in your toolbox as far as hey, let's see what happens if we toss in a little bit of Sasabit, see how this does with our rutting. I do know that the inclusion of Sasabit does increase the softening point, obviously in old binder tests, up to about 6 degrees Fahrenheit. So it really stiffened that liquid. In 2021, we had 94.6 million tons of wrap produced in the United States. That's a lot of wrap. And so, like Nathan said at the beginning, we're really pushing the boundaries of the amount of wrap that we're including in our mixes. But some tips or some processes that really need to be taken care of and really focused on is, no matter the percentage, you basically want to get accurate wrap characterization. It's critical for accurate wrap characterization when we're dealing with wrap, especially in high percentages of wrap in our mix designs. And we're talking about asphalt content, gradation, trying to get as accurate a bulk specific gravity as we can. And if needed, fractionate. Fractionation is very popular in the lab and in the field to try to get more control over our wrap. And I also want to talk about keeping consistent heating and mixing procedures, especially in production when we're looking at volumetrics between contractor and agency, and if there's multiple labs in the same contractor where we're comparing mixed production results. Okay, so we need to really focus on everybody having the most consistent heating and mixing procedures when we're dealing with wrap. There's a couple of tools that you can use in your mix design procedures. One being the NAPA Resource Guide or Informational Series 146. There's a photo of it here on the slide. It's the impact of lab wrap heating for BMD properties. Now it's tailored toward BMD properties, but just if you take the BMD part of it out and really focus on how do we really need to handle our wrap in the lab. Okay, those tips and tricks that are in this guide they can pertain to any sort of mix design that we're doing. Okay, it doesn't have to be in BMD. It can be Marshall. It can be SuperPave. Okay, so just the procedures in the guide are very important. The second thing that's on the slide is the guys here at NCAT. They did a really good job putting together this NCAT trial weight estimating spreadsheet. So it basically, it's a multi-tab spreadsheet that gives you areas to input parameters for your mix, and if we want APA samples, if we need to make TSR samples, it gives you this weight estimating spreadsheet, or so it automatically gives you, hey, if you want to make TSR samples, you need to start with this weight. Okay, so it basically takes out the trial and error portion of mix design when we're talking about making samples to a specific height when we're dealing with our different performance tests that are required for our criteria. The QR code basically just takes you to the link to the trial weight estimating spreadsheet. Okay, so that's all I got. So short and sweet. So hopefully the information that I presented, you guys can take to your lab just to give you some tips and tricks if you're dealing with any kind of alternative or non-standard material in your lab.
Welcome everyone. My name is Satish Branda. I worked in mixed design business for a while. Currently, I work for Sunland and Saltera Materials. Working for the producer and contractor, my thoughts will be more towards how do I control this mix during the production and placement, and how to plan that during my mix design. With that, let's talk about asphalt rubber design. During this mix design, first you have to prepare your asphalt rubber, and then you use that during your mix designs. I don't want to go through like a lot of these procedures, but I want to share what we need to do during doing this lab process. Here are some ADOT specifications. You use type 1 for hot regions and type 2 and 3 when you get into cold regions. During this mix design process, you have to dry the crumb rubber so that it won't foam. If there is a moisture, it will foam and it could cause some problems. You have to introduce the crumb rubber slowly. If you put too much into it, it will swell and again it overflows the container. ARB, you have to put this in a loosely covered container, otherwise it will build some pressure, right? How to use the forced draft oven. You cannot use the hot plate or anything to get it to the mixing temperature when you are using this asphalt rubber during the mix design process. You have to thoroughly stir all the time to make sure the rubber is uniformly distributed in the can. Otherwise, there will be some settlement and it is not good. During the mix design process, any mix design, you have to clean those bowl and whip or any mixing equipment you're using. Otherwise, those binder rich fines, the fines has a lot of oil in it. You will lose in your first point and you will put those into your next point. The whole point of doing those trials is to see how your asphalt content is affecting the properties while you are increasing it. So if you don't clean these mixing equipment, you will have some problems. Your design will be all over the place. Here are some tools we use. We trim this to align towards the bowl so that we can clean the bowl. You can use some like the weed puller or spatula to clean the whip. After you clean, you mix all those fines back into the mixture, blend them, and then use it. Do not heat asphalt rubber for a longer time. If you do that, it may create some problems like with the binder. Like Graham said, during these mix design procedures, when you're doing, there will be a rise or swell. If it is rising or swelling right after your compaction, it is showing like there is not enough room for the rubber. So you have to readjust your composite and redo the all process again. You have to leave that specimen in the compaction mode to cool off until it is safe to extrude. Otherwise, you may damage the specimen. After curing the rice samples, spread it in a pan. Use of this release paper helped me a lot to clean up those fines. Again, all those fines you have to include in the mix design. With that, let's talk about wrap. When you're using like high amounts of wrap, you have to fractionate at the plant and also like in your lab, like Graham mentioned. It is very important. So if you screen and separate the dry wrap to all the larger sieves up to number 8, and you put -8 into your another bin, it will help you while you're batching these wrap samples during the mix design to keep it consistent throughout the process. This binder content of the extractor wrap, gradation needs to be determined. If you are using ignition method, it has some advantages and disadvantages. Every lab will have an ignition oven. But sometimes if you have to use the solvent extraction, only few labs have it. Both methods has other advantages and disadvantages. So during the mix design process, if your procedures are to use ignition method, you can use the solvent method during the recovery process because you have to do that anyway to classify your binder. So during the recovery process, use one of those batch samples. You can do the weight before and after to calculate your binder content, and then you can use the extractor wrap for your gradation. Especially if you don't have an in-house equipment, this process is really time consuming and expensive. So save all that extracted aggregate during this solvent process so that you can use it in further testing. Again, like getting these both ignition and solvent extraction data will give you a lot of information. You can see how much binder difference is there between the two processes. You can see how much passing 200s difference is there if there is any burn down of that material during the ignition. All these are very important. You can see if there is a breakdown in the aggregate, which will give you a lot of good information beforehand. After you get your true grade during the classification of your wrap binder, always share that with the binder supplier that is supplying you the virgin binder. Sometimes they can formulate some binders to help the process to meet the final binder classification, like the target binder classification. Once you decide your virgin binder and you have the wrap binder information, if you don't have an in-house binder testing lab, it could be a very time-taking process if you outsource it to get the binder classification. So establishing how much wrap I can use and all that through the blended binder classification first could be an issue. Like I don't have an in-house binder lab, so what I will do is I will first use the maximum allowed wrap in my trials and see where my binder content is. At that point, the only unknown is you don't have a mixing and compaction temperature of your target blending binder, but you can estimate that by looking at the binder mixing and classification temperature of that grade you're trying to meet. I usually use little bit on the higher side because I'm expecting my binder temperature usually after blending the wrap binder is little bit higher. That way now I established my total binder content as close as possible. Then if you do the blended binder classification later, if it passes and if the temperature falls within the range you used, then you're good to go. If it fails, you have to adjust your wrap content or you have to increase your target binder content. By then you'll have a lot of information to have a best shot to pass the classification. Always batch wrap in two separate pans so that like during the mixing process, you can, if there is a mineral admixture involved, you can wet mix that with all the virgin aggregate. put it in the oven, let it dry and reach the mixing compaction temperature so that you can add the wrap as minimum time as possible in the oven. And you have to keep that time of that wrap in the oven consistent between your trial points so that again you are trying to see how the binder content is affecting the properties when you are doing the mix design by increasing that binder. So you don't want any other variations during your mix design process. And there are so many studies done there how you calculate the specific gravity of the wrap aggregate. We do the rice test on the wrap. There are some discussion there, like it is really tough to do the dryback procedure on the wrap rice. So some states use some virgin binder, they add it to avoid that issues. Whatever the procedure it is, it has some advantages and disadvantages because in our procedure, we assume the absorption of the binder. It could be same or more or less, depending on like where you're getting the wrap from, if you don't have the history. It is always good to, if you find there is no breakdown during the ignition process by comparing with your solvent extraction gradation, you can use sometimes that aggregate. It is easier to get more aggregate extracted from the wrap using the ignition oven. Even though your procedure asks you to do certain way, it is always a great information if you obtain all that aggregate and do some aggregate properties on that. It is very good, helpful information. If all that material you recovered or extracted during your recovery process, if there is a breakdown, you can use that to measure the properties, determine the properties of the wrap aggregate. All this information, regardless of the procedure you have to follow, you can use those to see how these mixes work, because like if you're using ignition method in your mix design, if there is a lot of the difference in that passing 200, especially on the fine wrap, it will help you to see by using the solvent extraction method, just plug it in the spreadsheet and see when you are designing these mixes. It is a very good information. So mixed designs with aggregates from different sources. Like Graham mentioned, if you have a large difference in the specific gravities, there will be a lot of problems in the production, right? If you change these during the mixed design or in the production, you will change like the densities, like the densities will shift either going to higher or lower, depending on how you are changing your bin proportions during the production. How do we deal with it? If you don't, every day there will be a confusion, like the rice values go up and down. If your agency uses the average of the price for the lot for the day to calculate the in-place compaction, then it will be all over the place and causes problems. Some, even though it's not over-compacted, the results will show it's over-compacted or vice versa. So it is very important to control these and plan these during the mix design itself. Because if not, there will be so many issues during the production. How can we do this? Like I have these two examples. Let's say we have a project, a large highway project you won, and you don't have anything on the ground yet because like it's not awarded yet. The contractor is trying to see if they get the job first. Now, you don't have, it's a mill and fill project. You don't have a wrap file ready to go to test. You have to go get some cores throughout the project as uniformly distributed on the whole project. You have to bring that, crush it in the lab using a small jaw crusher. So not my favorite procedure, but what can you do? The traffic is still on and you're not allowed to go there to get all these cores the way you want. Sometimes it's on the shoulder. Then you start crushing the pit in the pit close to the project. Then you see like you have to borrow some more material because of some issues. Like let's say there is a vesicular basalt in the pit, like you cannot use the coarse aggregate because it's absorbing a lot of asphalt. Or let's say there is like a moisture sensitivity issue, then you have to borrow some fines from somewhere. There is a carbonates issue, there's a lot of polishing, so you cannot use that coarse aggregate. But you want to borrow from other sources that will add a lot of haul cost. So you want to minimize the borrowing. So how do you plan that? Like as a mixed designer, I see all these first. So I have to think about how do I plan this in the mixed design, and also how do I plan this during the production control so that it will be successful. My mixed design is successful only if it can be produced and placed without any issues. So here is an example, like always source 1 is what we have close to the project. Source 2 is where we borrowed the materials. And there is that project millings that you will get during when the project is started after you are done with your mix design using your lab crushed wrap. So I cannot change a lot here. During the production, you can adjust your processing the wrap operations to what we come up with in the mix design process. And you leave it there, like the change between these two coarse and fine wrap has to be just adjusting the wrap to the actual wrap binder contribution we have during the mix design process and the gradations. So I cannot change a lot between these. Now, when you have these crusher fines, let's say in this, we have to borrow a lot of rock from some other source. So I want to reduce the cost here to use a lot of the fines I have at this project. So ADOT gives us an option to use either Marshall or Super Pair mix. When I can use a lot of fine material, I choose Marshall mix because the mix uses a lot of fines. During the mix design process, I want like let's say the pit is in middle of nowhere, there's no source of water. At least we have to use the air separator to clean up some fines so that during the mix design process and also during the production, I can control the volumetrics based on these two products. And when you borrow from the second source, bring both aggregates so that if there is some adjustments need during the production between the coarse aggregate on the coarser side, I can change those proportions between these two from the same source. Same thing here, if I change those bin proportions between these two products from the same source, then I can reduce that problems during the production. If you have a intermediate aggregate between the same source, then if you have to increase or decrease the fine aggregate proportions, I can use these three products to control that. So all this planning, like during the mix design and what will I do during the production, will help to keep those problems little bit less. Here is another example. You have a great rock, but there is, let's say there is a moisture sensitivity issue with the fines we have at the source close to the project. So you borrow some fine aggregates from some other pit. Since the rock is good, now I chose to do super pave mix so that you borrow less amount of material from other source. It's a cost effective, and with the same concept here, you can change those proportions between the same source so that you are not affecting lot of other things while you're trying to do that. This not only just densities and absorption, if these are coupled with some other properties, like let's say there is a angularity difference between the fines between two sources, it just complicates things. So always choosing during the mix design process how you change the bin proportions when you have to do during the production is a good thing to do. So during the mix design, like it is very good thing to think about all this. The reason I'm sharing this is like for the people that are trying to get into the mix design business. It is very important to think all this during the mix design so that you are ready for this. With that, thank you. I'll transfer this to Travis.
What are some lessons learned, or maybe a summary of this? I'm going to go back to the basics, and I think Graham did a great job of talking about that. And Satish did as well. Basic material properties and mix fundamentals are important. Sometimes you hear the joke about turning our roads into horizontal trash cans, right? Like we need to understand what these materials are doing to mix, to the actual content, to the binder stiffness, to the gradation and the density, and so forth. It's okay to adjust rules of thumb. It's okay to adjust. If you've been running a mix for a decade and it's kind of always been in the same window, but then you want to swap out light or heavy aggregate, or you want to put some rubber in there, it's okay to make changes, but do it carefully and do it with thought, right? Because as you do add new components to the mix, things will change. And consider performance. I mean, a good mix designer can put anything in a mix. Really, a good mix designer is going to be able to put as much junk in there as they want. But consider what it's going to do to performance. And then finally, I like Satish's example of pay attention to potential compatibility issues with your existing equipment, your existing procedures, and these additional materials. So with that, I want to thank both Satish and Graham for your information. That was really good. And we're monitoring the chat, see if there's any questions. So we have a few minutes left over for questions. If anybody has questions, go ahead and please feel free to type them into the chat box.
Awesome, Nathan. Thank you. Nonetheless, so one of the questions that I have gathered in through there is that we've talked about several different types of these non-traditional materials that are being used in the mixes. Graham, I wanted to ask you real quick, which one of those materials do you think has the greatest effect on the specific gravity of our mix, which in turn is going to affect, obviously our GMM and our bulk specific gravities there?
I would say if you're dealing with a heavy aggregate and we'll call it a lighter aggregate, you got to think about what volumetric properties are being driven by by GSBs, and obviously the biggest one would be VMA, voids mineral aggregate. And if we can increase the overall bulk GSB value of our mix, it's going to give us the best chance to meet VMA properties. So if we're having trouble meeting VMA, and we substitute a little bit of a heavier stone, obviously that's going to give us higher compacted bulks, but it's going to give us a greater chance to also meet our VMA requirements, depending on the mix that we're designing. So I would probably say that the heavier stone.
Okay. Great.
And Travis, you didn't ask me, but I would also say, sort of second to that, high absorption aggregates will have a pretty large effect, maybe unexpected effect on your GMM if you're not paying attention to it, or if you've got the only thing worse than high absorption is variable absorption, and that can really send your GMM squirrely.
Yeah. And I know our friend John Crane that you're spending some time with there this week he's in West Virginia. He did his research for his master's degree on some blast furnace slag that had that variable absorption, and it was a real problem for some of the contractors in that area. So
Oh yeah.
great point to bring up. Satish, what material have you found has affected that the most in your mix designs?
So most of the time, if there is a commercial plant, you figure it out all the issues, right? And you already set your stockpiles to make it work. But most of the time when we go to these mill and fill projects, I use that word a lot, like in the middle of nowhere, you don't have a lot of options. You find a pit close to the project, you want to use it. So what if you get into a vesicular basalt pit that absorbs a lot of asphalt and water absorption, and you are stuck with it? Those are the times that you see this lot of absorption issues. ADOT pays for the binder, so they limit that asphalt absorption to 1% so that they don't pay for the extra binder we're putting.
Yeah.
It varies. That absorption varies during the production. It causes the dries to go in different ways, causing confusion for the person controlling the compaction, and a lot of things.
Great. Nathan, I've heard discussion in the past, especially when it comes to like the dry process with rubber and trying to put a certain percentage of that rubber into the mix in that dry process. I've heard folks talk about needing to go with a volume replacement rather than a weight replacement there. Could you speak to that for just a minute?
Yeah, I'm not sure every reason why someone would say that, but the primary reason that I've heard is similar to what Graham discussed about blending. Essentially that if you have to fit that rubber into a band, that dry rubber is not going to melt, so it's almost acting like an aggregate. It's not an aggregate. You should treat it separately, like Graham showed, but you have to make room for it. And so if you're putting in 1% rubber, just as a made up number, in reality, 1% by mass is much higher by volume. So and then Satish brought it up. If you've got a bunch of swelling and rebounding and expansion immediately out of the gyratory, that can indicate that you don't have room for the rubber you put in there. And you may think, well, I only put in 1%, or maybe I only put in 0.5%. Well, that 0.5% kind of ballooned into 1 to 2% or whatever by volume.
Yeah.
And it could cause, it can cause problems because all of our volumetrics are not based on mass. They're based off volume. Voids are based off of volume. They're kind of blind to the weight of the material.
Yeah.
Yeah, we have some challenges while working with the plastic when we added it to the dry aggregate. Not all plastic will melt sometimes.
Mm-hmm.
When we sheared it into the binder, it worked well for us. Some information there, what we face during the mix design process. You have to match how you are doing it in the hot plant. So there, we have better experience adding it to the binder.
Okay, great, great. Graham, anything further on that topic?
No, I think it was pretty good, pretty well discussed.
Okay, sounds good. I've thrown everybody's email address that's here today up on the screen here so that we've got this. Do want to mention that if you'll visit us at ncat.us, that you can find all sorts of our research and find further information on the topics that we cover with these different webinars that we have. Always want to say, if you get a chance, visit our Training in Your Pocket series that's on YouTube there. Please subscribe if you will. There's more of those coming out. We're excited. We've got a couple of those we're scheduling to film in the next month or so. We're really excited to push those out and share those with the asphalt industry as a whole. There's always opportunities for training. We travel quite a bit with that kind of stuff. We can come to you. You can come to us. We've got mixed design and balanced mixed design courses that are coming up next month. So if you're interested in that, that'll be a chance for you to come and visit us at NCAT. You'll get a tour of the lab. You'll get a tour of the test track and so forth. Also want to mention this is a reoccurring webinar. And so we are set for March 20th is our next version of this. We are still working on making sure we've got a topic picked out here. So the topic's to be determined. We had something set and we've decided that we needed to shift a little bit. So we're going to pick that one. That QR code is already updated though. So please watch for your emails or social media, wherever that is that you normally get the notification for this webinar. And we will be announcing that shortly. But we look forward to seeing you folks the next time. So given that, we'll sign off from here. We appreciate everybody's time and look forward to seeing you next.
Thanks, everybody.